Hi everyone, my name is Quentin Bramas and I'm going to present a short paper about a new tip selection algorithm for the tangle. So first, what is the tangle? The tangle is the data structure storing the transactions in the IOTA cryptocurrency. So maybe you are more familiar with Bitcoin. In Bitcoin, transactions are stored in blocks, forming a tree of blocks, and we consider only the longest chain to be the valid one. That's why we call it the blockchain. In IOTA, each transaction has two parents instead of one like in Bitcoin. Hence, we end up having a directed acyclic graph, a DAG, which is called the tangle. One fundamental building block of the tangle is how do we select the parents of a new transaction. This algorithm is very important as the security and the stability of the protocol rely on it. The algorithm is called in the literature a tip selection algorithm, a TSA. And we use the term tip because a parent of a transaction should be an extremity of the tag. That is called a tip. In previous work, several TSA were presented, and now I will just explain some of their behavior and how they can be improved, and you can see more details in the paper. The previous TSA all have in common that when we want to select two parents of a new transaction, we first look at all the tips of the tangle, and we select randomly the two parents using some randomized algorithm. For instance, we can select them uniformly at random, or use, for instance, a random walk starting from the genesis of the tangle towards the tips. And the tips where the random walk ends will be our first parent, and then we can run it again to have a second parent. So the later method has the advantages that the random walk could be weighted to increase the probability that we select the tip in the well-confirmed part of the tangle and avoid other parts of the tangle that could contain malicious or conflicting transactions. IOTA used the random walk algorithm, called the MCMC for Monte Carlo Markov chain. However, one problem with the MCMC algorithm is that it is expensive to compute. More precisely, it relies on the cumulative weight that is expensive, and a fraction of the transactions are never confirmed. They are called left behind. This is quite complex to analyze, so if you are interested, you can look at some reference in the paper. The main observation that we make in our short paper is that resolving conflict should not be done in a randomized fashion. Indeed, regardless of the method you use to resolve conflicts between two transactions, for instance A and B, even if you think transaction A is correct with maybe 80% likelihood, then you should always consider A as correct in the deterministic manner, and not consider A correct 80% of the time and B correct 20% of the time. Because the goal is to build on top of what you consider correct to increase the likelihood of it being correct. And that is not what is happening with MCMC. With MCMC, you have a small probability to confirm malicious transaction. It's like if Bitcoin, the longest chain principle, was replaced by a probability based on the length of the chain. So this is not done in practice, and it will create some problem. And this is what MCMC do. So in practice, this is not a big deal because with MCMC, the probability decreases exponentially fast. So that to confirm a left behind tips. So it's not really a problem, but the behavior could help the adversary when we are in some tangent configuration. So with this observation, actually, we see that it is better to split the TSA in two parts. One part that resolves the conflict
in a deterministic manner in order to obtain a conflict-free set of tips, and the other part responsible in selecting randomly the tips among the conflict-free set of tips. And now we can have the best of both worlds, an algorithm that is more secure than MCMC and as efficient and stable as the uniform random algorithm. So the algorithm will look like this. You look at all the conflicting transactions in your triangle, you resolve the conflict, so between each pair you decide which one is correct with the more probability, with the greatest probability. And once you resolve your conflict, you can compute the set of tips that confirmed or that at least do not conflict with the confirmed transactions. And from there, you can uniformly at random choose your tips as parents for your new transaction. So as a side note, I want to mention that, if I'm not mistaken, the new protocol that will be deployed for the IOTA cryptocurrency called the coordicid already solved this kind of problem in a different manner. But I'm not very familiar with it, so this could be something interesting to look at in the future. So thank you for your attention.